So let's take this up because it's a little bit. Seems like we're having a little bit of trouble starting. Now I gave you guys a big hint of solving problems. Where to start? Visual. How are we going to make this visual? Draw it. Right? Half the people in this class didn't even bother drawing a rectangle.
Oh,
so here we have a rectangle. So this is our park. Right? It's all grass. We know the size of this park is 100 meters by 60 meters. Okay? So what they want to do is they want to build a path, right? So it's not to the outside because there could be stuff around. Maybe it's surrounded by streets or whatever. You can't. So what is it? They want to add a path on the inside. So we'll draw a little path all the way around. Man, this thing is really off. Okay. So here's a pathway. The question is, how do we get a path in here, right? What's the maximum size of that path so that we don't take more than 10% away of the grass? Right? We don't want to reduce the area of the grass by more than 10%. Okay? So first of all, what's the area of the grass right now?
6,000.
So area of the grass, or park, is 60 times 100. So 6,000 square meters. So what's the smallest size area that we could have in here for a new grass? What's the smallest size in terms of the area? What's the smallest area that they have? Scale. How'd you get 5,400?
What?
Divided by 2. What we're going to say is,
Divided by 10.
so new area is really the old area, 6,000, but we want 90% of it. So we want 90% of the old area. So that's equal to 5,400. So that's the size of the area, the smallest can be of that new patch of grass. Okay? What is the dimension of that rectangle? Hard to say now because we have no variables.
But I don't understand. If you reduce the area by 10%, wouldn't the new area, or wouldn't like the area of the path be 600?
Well, the other equation that you have is another way you could looking at it. Is area is 6,000 minus 10% of 6,000. That's the amount of grass we want to remove. That's the amount of grass. So here, this is the amount of grass that we remove. We can only remove at most 10%, right?
Okay, but it says what the maximum amount of area for the grass
does not reduce the area of the grass. In other words, we don't take more than 10% away of the grass.
Exactly. So wouldn't the thing be 600?
Yeah, at most we can only take away 600. We do not reduce. Does not reduce. So Christian, what does this mean? Does not reduce. Let's call Miss Church on there. Miss Young. Your English teacher.
It does not exceed 10%.
Does not reduce the area of the grass. What does reduce mean?
Minus.
Yeah, we do not reduce, we do not make it smaller by more than 10%.
So the park would be, this would be the area of the park.
The amount of grass in the park would be 90%. You lose 10% of the grass in the park after the pave.
For the path.
For the path, so what's left? How much grass is left there?
I think it was, okay.
Oh my god.
I'm saying, the park left. What's left of the park after you,
The path, how much grass is left?
then it'd be 400.
That's what we're looking for this area in here, which is the blue.
But aren't we
Right.
trying to figure out the path, which is 10%?
I'm just saying, yes, we're trying to figure out the width of the path, but before we get there, I'm just trying to put this problem in context. So that's why I'm saying slow down when you come to these problems. You don't have to get to that answer right away because you might need some additional information to get you there. So here I'm just trying to put things into context, adding information based on information we already have. So we already know that the dimensions of the park is 60 by 100, right? We know that we're going to have a path in here, but we want to also know that we're also given this 10%. What does that mean? That means the area that's left over of the grass, it can be has to be at least 5,400.
But why do we need to know 5,400?
We'll see. I'm just saying, get that information now.
So live. I don't understand.
Christian. All I'm saying is get this information now. Don't try to solve the problem yet. Because this is why, one of the good reasons why we're sort of lost when we go solve word problems. We think, oh, I gotta get the answer right away. Well, we need to take a step back. We're given some information. How can we extend that information to get more information? And chances are that more information is gonna help us solve the problem. Okay? So, before we can actually figure out this, help us figure out the area, we're missing something here in our diagram. What are we missing in our diagram? Yeah, what are we trying to find? The width of the path, right? So let's just say that this is the width of the path. Yeah, it's really cool. It's driving me nuts. Okay? What's the width of the path? We don't know. That's what we need to determine,
Or the path.
right? So we're gonna assign that a variable,
20 by 30.
right? So let's call it P. P for path. Okay? So given that this is P, this is P, I mean we're gonna have the same width of the path all the way around the park, right? Yes?
Yes.
So what is the area of the smaller rectangle? So the new area, how can well, we know it's 5,400, but what is its dimensions? What are the dimensions? What are the dimensions of this rectangle? So I'm going to redraw it here. So what are the dimensions there? What are the dimensions?
Of the smaller one?
Yes, of
Each
the
side
smaller
is 10%
black rectangle.
smaller.
We don't know if it's 10%.
54 and
In fact, it won't work out to be 10% because that's not how area works. Just because you reduce your area by 10% doesn't mean that your length and width gets reduced by 10%.
It's reduced the length and width.
Subtract the P. So this is 100 minus P? Yeah.
Smart.
Oh.
Because we have the path on both sides, the length, this side is actually 100 minus 2P. And what's our width of the new area?
P perimeter?
P is for the path,
What would be 2P?
because we have a path on each side, right? P is just for the width of the path, because the path exists on both ends. We have to take off 2 times that. So what's the width of this? What's the width of this rectangle then? So what's the width of this rectangle?
60 times 2P.
times 2p
minus 2p.
minus 2p. So now, Christian, this is why we wanted the area of that rectangle. So what we have is 100 minus 2p times 60 minus 2p, right? That's our formula to calculate the area of the rectangle, length times width. This is equal to what? What's the area of this rectangle? 5,400. So now do you kind of see why we needed that 5,400, Christian? Didn't see at the beginning, but just try to get whatever information that we can before we try solving the problem. Yes, Michael?
I'm still confused. Like, I understand where you get the 2p from, but why do you do it? Like, I understand the length of
Why am I doing what?
why are you doing 2p?
Because here is a path, right?
Yeah.
P is the width of the path.
Oh.
The path exists on both sides. So that's why there's two of the widths. There's
Oh,
two
I
of the
see,
widths
I
of
see.
two of the widths of the path that we have to reduce.
And then you're subtracting it to get rid of the space.
Well, we subtract it because that's the length of this new rectangle, right? That's the length of our new grass once we put in the path, right? Because we lose p over here and we lose p over here, so it's 100 minus those two paths that we're losing, right? So the same thing applies to the width. So now that we have this equation, how can we solve for it? Expanding.
I did in my
You expanded and then you factored.
Isolate
Yeah.
P.
That's what I did.
Should isolate P.
Like why though?
Because
Okay.
I like
So you expand it, so you expand
Michael.
You have to break it down because then you gotta find out like the roots.
Yes, thank you. So in order to solve for a quadratic equation, right, if we can have one side equals 0, then if we could factor the other side, then if any of those factors equals 0, that gives us a solution to p in this case, right? So the key is that we need to get 0 on the other side. So I could do this as my first step. 100 minus 2p, 60 minus 2p, minus 5,400 is equal to 0. But is this in factor form?
But why don't you just isolate P?
I could. How are you going to isolate p then?
Expand.
Exactly. This is what we're trying to do is isolate p. Yeah, so what we have to do in this case, we have to expand. So I'm just demonstrating this first part is that we want to set one side to 0, right? So that we could try to solve for 0. But by doing just subtracting negative 5,400, this is not in factored form, right? We need it in factored form in order to help us. Okay, so if we expand this, we got 6,000. Negative 2p times 60 is minus 120p. 100 times negative 2p is minus 200p. And then we got plus 4p squared is equal to 0. Oh, I forgot the negative 400. Minus 5,400 is equal to 0. So how can I simplify the left side?
Wait.
600 minus
Right? And you'll see this. All I'm going to do is expanding this. 100 times 60 is 6,000. 100 times, 2p, negative 2p times 60 is negative 120p. 100 times negative 2p is minus 200p. Negative 2p times negative 2p gives us 4p squared.
Wait, 4p minus 1. Oh,
Plus 4p squared. Okay, so if I simplify this, how many p squares do I have?
One.
Just one term, which is just 4p squared. Then I simplify the p's. Negative 320p. And finally, 6,000 minus 5400 gives us 600. Oops, minus 600 plus 600 is equal to 0. I don't know, what's the value of P?
You can
6.
take 4 out of that.
Oh, I could take 4 out of this. So really, I could divide 4 from either side. So I get P squared minus 80P plus minus 50 plus 150 is equal to 0. So question, what happened to the 4 that I factored out? I could put outside brackets, but really I'm dividing both sides by 4. What's 0 divided by 4?
Why don't you
0.
okay, never
Yeah.
mind.
So I could have did this, right? I really factor out the 4. By the next step, we're going to divide both sides by 4, but 0 divided by 4 just gives me 0, so the 4 really disappears. So how can I factor this part? P squared minus 80P plus 150.
Now
We can plug in the quadratic formula.
so it's practice. We turn it so it's perfect.
I could turn it to a perfect square. Minus 80 divided by 2 is 40, so that's going to be a pretty big number to work with. You want to complete the square on that?
I want to do quadratic formula.
I agree with what Ryan just said.
We need to practice our
Quadratic formula?
That is the way to go.
You can factor this, come on.
No.
I want to
It
factor
has
it.
to be in school or on the test.
Factor for
What?
500.
Word problems.
Solving problems, yes.
No.
This is what I'm going over with you, Liz.
No.
No.
There's tennis next class.
Sorry? Test is on Monday.
Monday.
I thought it was next class.
So really, this comes down to exercise. I can ask you this on the test. Solve for P. Right? That's all it is. Solve for P. But you just have to get that equation somehow. You guys want to use the quadratic formula?
Yeah.
My least
My
favorite thing.
favorite. Football.
So P is equal to minus B plus or minus square root of B squared minus 4AC all over
Does
2A.
anyone remember this yet?
Yes.
Are you serious?
Yeah, I got it.
It's on the calculator.
You've done all your homework early.
So here, what's the value of A? What's the value of A?
1,
1. What's the value of B?
320.
Negative 80.
Negative 80.
Whoa.
And 1.
Right? We factor out the 4 there, Dale.
Oh, that's an 80. I thought it was
C is 150.
an
So plug that into your calculators. What are you going to get?
Wait, what's wrong with B?
Sorry?
What's wrong with B? Is that
B is negative 80.
sorry.
So P is equal to 80
plus minus.
plus or minus the square root of 80 squared.
6400.
I'll just write it for now. 80 squared
81.
minus 4 times 1 times C is 150.
600.
All over 2 times A, which is 1. So P is equal to 80 plus or minus square root of 6400 minus 600. All over 2. So P is equal to 80 plus or minus square root of 5400. Does that work out nicely? No, it doesn't. So it's 5800.
Yeah.
All over 2. So work down your calculators. What's the square root of 5800?
70.
80 plus or minus what?
6.2.
76.2? So here P is equal to 80 plus 76.2 is 156.2 all over 2, or P is equal to 80 minus 76.2 gives us 3.8 over 2. So P is equal to 156.2 divided by 2 is 78.1. Or P is equal to 1.9. Thank you. Done, right?
Yeah.
It's all for P. Sorry? There's two answers, but that's okay.
Oh, I know. The line.
Why 78? Why can't I have a path of 78 meters?
It'll be negative.
Why would
Why
No
is
sense.
P 38?
Oh, you got to
So,
Well, in the end, I got 78.1 and 1.9, right?
Why is
I know.
What is it, Mike? Oh,
You get your area from before. Well, first you gotta figure out the new area of what's inside of the grass that's remaining, and then you once you figure that out, you do 6,000 subtract the new area, and if it's greater than 10%, you know P is right. If it's greater than 10%, you know P is wrong.
okay,
Less than 10%, you know P is right.
okay, so that's one way of doing it. Well, can I have a path that is 78 meters wide?
Depends how big.
no.
Oh no.
My field is only 60 meters wide.
Oh.
So this answer over here does not make sense. In fact, if we use P as 78 to figure out dimensions, 60 minus 2P will give me a negative answer, right? So that, yes, that's what you're getting at. So without having to do the math though, we can just look at it and say a path of 78 meters makes absolutely no sense, right? So here, therefore, path is at most 1.9 meters. It's important to say at most, right? Can the path still be 1.5 meters?
Yes.
Yeah.
Yeah, right? I just still have more than 90% my area, that green, the small rectangle, which is bigger now. But it just can't be more than 1.9 meters, right? So the path is at most 1.9 meters wide. You look confused so much.
Oh, that's 1.9. Sorry.
Sorry, 1.9. It's smart for in the other rooms, but we're gonna make sure to stay
You
there.
have to calibrate.
No, it's.
Like,
Question, Alex.
I kind of like missed the explanation for the P minus 2 or 60 minus 2P. I was like doing math.
You did this the bigger number.
So you're not paying attention while
I was working on my own, like.
which is
I
fine.
was trying to figure it out, but then I
If
missed
you
yours.
did this one, if you did this as P, and then 60 minus 2 and that, you get a negative, so you don't
Look
do
at
that.
that page.
No, no,
Jesus.
I know.
How long that is?
I know.
It's a tab.
This is why I do not like
Tab.
the quadratic formula.
So you're hurting me so. I love the quadratic formula.
So Alex,
8 meters.
Alex, so you have.
Because you went to.
You do it on the other page.
You kidding me? Yo, I say, you Alex.
You're
I
there.
said you
You
lied.
both.
So Alex.
I don't wanna make it-
No, keep repeating.
efficient work?
No, nothing.
This is your original park, right?
Yeah.
So we want to build a path inside, right? So we don't know what the width of the path is, right? So first of all, this is 100, and this is 60, the outside rectangle, right? We got 60 times 100 is 6,000, right? So with the 60, but this rectangle here, the smaller rectangle, what's the width of our path? What do we assign that? What variable? P. So this is P, this is P, this is P, and that's P. Right, we have a path all the way around with the same width.
Wait, what's width like? This way?
Well, the width of the path, how big the path is,
Okay, yeah.
right? So what is this dimension here now. What's 60, right? But we minus this p, because that width got taken away,
Oh, okay.
and then we take away this p as well. So then we get 60 minus 2p. And the same thing with the length. Here we got 100, but we subtracted this p, and then we subtracted this p. That gives 100 minus 2p. So that's how we got the dimensions of the inner rectangle. Okay, any other questions? Right? I mean, that honestly was the hardest concept to get out of this question. What was the dimensions of the inner rectangle? And then the subtlety is, what is the area of that inner rectangle?
So
At least.
That wouldn't be a rectangle, it's all P, so it wouldn't be a square.
P is not the dimensions of a rectangle. P
I think
is
that is
just
yes.
the dimensions of our path, right? The part that we're cutting out.